Good morning, intermediate algebra students. If you're watching this, must mean that I'm not in school today. So we're going to go over this lesson 5-2, and hopefully you will work really hard and learn really well for your substitute person. So here we go. First of all, let's just start with a little review on these type of chart problems again. So as you can see, Matt and his friends are going to take a day-long tubing trip down the Blue Earth River. Pretty thrilling voyage, I'm sure. They pay $15 per person for a tube and $7.50 per person or per tube to rent a cooler tube for carrying food and water. And total cost for all these guys is $360, and they have a total of 26 tubes. How many of each type do they rent? Now I've set up the chart like this for you guys. And so perhaps if the teacher there could pause this a little bit and just let you work on this problem and see what you can figure out. I will go over the answers after a little bit, but let's take a few minutes and see what you can come up with for the solution to this. Alright, here's what I would do. We had written down in there that we were going to have the regular tube is going to be, the number was going to be t. And remember, we want to have as few variables as possible here. The secret, I think, to this problem is to figure out what should go here, this particular spot. And we could use a different variable, but we're really not at that point yet. So the idea is we want to try to figure out what expression to put there. We know that they rented a total of 26 tubes. So what I'm going to write here is actually 26 minus t. We've seen that on a couple of other problems we've done, but that's the secret here. Notice if you do add these up, if you add up these totals, the t's cancel out, and you do get a total of 26 tubes, which is what we really have going here. Now the cost per tube for the regular one is 15. And for the cooler tube, it's $7.50. So we know that our total here is going to be 15t. We know that our total for the other one is going to be 7.5, and then in parentheses, 26 minus t. So there's my chart. When I do my equation now, I remember that my equation is almost always going to come from the last column of this chart. So it makes sense then. I'm looking for a total here. I do know the total cost for all these guys. So my equation is going to be 15t plus 7.5 times 26 minus t, and that's going to equal the grand total that they paid, which we saw was $360. Now we can do a little bit of multiplication here. I know that of course I can write down that 15t there, and so I'll do that. Now I have to do a little bit of distributing, right? I'm going to take 7.5 times 26 and also 7.5 times t. 7.5 times 26 is 195, and 7.5 times t is 7.5t, but remember I do need to have that minus sign in front of it. Alright, so far so good. Now I can combine these two terms here. Those are like terms that I can put together. So 15t minus 7.5t is indeed 7.5t plus 195 equals 360. I am then going to subtract 195. This is back to our multi-step equations here. So 360 minus 195 is 165. So I have 7.5t equaling 165. Last step then is to divide both sides by 7.5. I kind of have run out of room here, but I'll do that quickly, and sure enough my t value comes up to be 22. So that means they rented 22 regular tubes, and then if you go back and put in 22 in place of this t, 26 minus 22 is 4 of the others. So we have 22 regular tubes and 4 of the cooler tubes. So hopefully you're getting a little bit more confident on those types of problems, as I'm sure you are. Now we're going to go on to the next part of this lesson and getting into this chapter 5, and a few things for us to write down and talk about here. I think you'll find this lesson to be relatively straightforward, and some of these terms I think you will recall. A relation. In this chapter we'll talk about two main connections between variables. One is called a relation, that's what our focus is today, and then later on we'll talk about a function. A function is perhaps more widely used in most mathematics classes, but it's good to know about a relation as well. So as we said, a relation is a set of ordered pairs that represents a connection between two variables. So pretty much anytime you see any kind of variables and there's more than one, we can consider that to be a relation. And the two main parts of a relation are the domain and the range. Probably heard of those words before. Domain is your set of first coordinates. Almost always your domain is your x's. And the range, the set of second coordinates, almost always it's y. But it wouldn't have to be. It could be m and n, or p and q, or a and b. So domain is first, range is second. Really the main thing we're going to do today is just see if we can figure out all the different ways that a relation can be represented. Here are the 4 ways: ordered pairs, a table, graph, and something that's probably a new thing to you, maybe something called a mapping. So let's look at each of these ways on our next slide here. So let's say we have this relation that I have given up here. Notice it's just a set of ordered pairs. I have 4 different ordered pairs here. That's considered to be a relation. Is it a function? Well, we'll find that out in another day or so. So if I was going to represent these in a table, all I have to do is write them down in the respective column. My x's, of course, are my first values, so those are going to be 4, -2, -4, and +1. And my y values will be the second values in the ordered pairs: -1, +3, -3, and 0. Very similar to ordered pairs, really. It's just we're writing them in a little bit different format here. Alright, now as far as graphing, I think all of you guys know how to graph ordered pairs. We actually skipped that lesson. But remember, when we graph, we first of all go horizontally. So the x values will be going along this x-axis horizontally, and then my y values on the vertical axis here. So in graphing each of these points, the point 4, -1, I go 4 to the right and down 1. So there's 4, -1. -2, 3, -2 to the left, and then up 3. So there's that one right about there. -4, -3, so I go -4 to the left, and then down 3. So 1, 2, 3, 4, and down 3, so it's going to look right about there. And 1, 0, so we're back into this one right here. Again, that's right about where they are. By the way, sometimes we talk about quadrants. Let's just refresh your memory on those a little bit. Quadrants are part of the grid here. We say that the first quadrant is right here, and the second, the third, and the fourth. That's something good to know. We'll talk about quadrants quite a bit from now on. And then sometimes we ask, well, what point is in what quadrant? And that's not too tough. If you have a point that's right on a line, like the point 1, 0, we say that's not really on a quadrant, that's on the x-axis. Alright, getting back to our representations for mappings again, or excuse me, for relations. Here we have the third one. This might be kind of new. This is called a mapping. very similar to a table. I just write down all of the x values, so to speak, like this. I'm going to write down all the y values, except I'm going to kind of scramble the order a little bit, like this. And then I just connect them up from one to the other. And so I'm going to use a different color here. So notice that 4 is matched up with -1. So that one, I just draw an arrow there. And it is important to put the arrow because the mapping gives you the idea that one of these variables is taken to the other. So we start with this one and it's kind of transformed into this one. That's kind of a good idea to keep in mind. -2 then should be matched up with +3, so that's down here. -4 is matched with -3 like that, and 1 is matched with 0 like this. So that's called a mapping. Pretty easy, but maybe a little bit of a new concept for you. And our last idea here, and that's something called the inverse of a relation. The inverse. You might recall that we did some inverse stuff when we were doing variations, and here it's about the same, not even that difficult though. If we have our original relation that we saw before, all we have to do for the inverse is switch the coordinates. So in other words, all the x's become y's and the y's become x's. So if we write down our inverse for the function we're given here, for 4, 1, 4 -1 becomes -1, 4. And -2, 3, of course, becomes 3, -2. Next one becomes -3, -4. And your last one becomes 0, 1. That's all we mean for an inverse. Inverse has some pretty important applications as you get higher in your math classes, but for now this is all you need to know. So you're going to be working on this 5-2 assignment today, as well as anything else you need to on your assignment card. So good job, and we'll see you guys soon. Bye now.